Hi everyone. Today we're going to be doing something different from what we normally do. So what we're doing today is we're going to be finding some different forms for writing the equations of lines. So there are multiple ways in which you can write the equation of a line, and we're going to be discussing some of them today. So the ones we're going to talk about today are the standard form, secondly, we have the slope-intercept form. And lastly, we have the point-slope form. So these are the three forms for equations we're going to be talking about today. So first of all, let's get started with the first one, which is the standard form. So the standard form of the equation of a line is usually written in the form ax plus by plus c. So with this, we have a couple rules. So usually, not usually, so over here we have A, B, and C, and these three are all constants. And then secondly, we have the fact that x and y are variables. So A, B, and C are all constant, meaning they don't change their value, but x and y have different values which change from time to time, which change at different values. So, and lastly, we have A and B cannot both be 0. That means they both can't be 0 at the same time. So they both can't be 0. Now, let's talk about the second form of a line, of the equation of a line, which is the slope-intercept form. Oops. So the slope-intercept form is a bit different, and to explain this one, I'm going to use a line. So slope-intercept form is written in the form y is equals to mx plus b. Now, this may not really make a lot of sense to you right now, because what is the m and what does it stand for, and where did this b come from? So let's go ahead and talk about this. So first of all, let's go ahead and discuss what m is. So m is equals to the slope. So that means so to find the slope, we use the formula y2 minus y1 divided by x2 minus x1. And then y2 minus y1 is, well, this stands for the change in the value of y, which we can also write as delta y, and x2 minus x1 can also be written as delta x. Now, to make this clearer, I'm going to go ahead and draw a line right here. So this is our line over here. Now, we can go ahead and, well, put 2 points on this line. And they're going to be right here, x and y. So our first point is x and y, xy, and our second point is 0b. Now, normally this would be ab, but since we know that this is our y-intercept, we know that x must be equal to 0, because that is where the y-axis is being intersected at. So this is 0b. Now, how are we going to use this formula over here? So what we're going to do, we're going to go ahead and write we're going to name one point as 1 and the other point as 2. So I'm going to go ahead and keep this point as 1 and this point as 2. So what does that leave us with? Well, we can go ahead and look at the values of the first point, which is 1. So we can write the 0 as x1 and b as y1. And then for the second one, x would be x2 and then y would be y2. So what does this do though? Well, we can go ahead and substitute the values for y2, y1, and x2 and x1. So that would give us y2 is y, so that is y minus y1, which is b, divided by x2, which is x, and then x1, which is 0. So y minus b is divided by x minus 0 is equals to y minus b divided by x. So now, if you look at it, we have m, which is the slope, is equals to y minus b divided by x. Now, let's go ahead and take a closer look at this equation. So we have y minus b divided by x is equals to m. Now, if we take x and multiply both sides by x, that would give us y minus b divided by x times x is equals to mx. Now, over here, the x and x would cancel out, leaving us with y minus b is equals to mx. Now, I think you can see where we're going with this. We're just trying to derive this equation over here. So to do that, all we're going to do is add b to both sides. So that would give us y minus b plus b is equals to mx plus b. B would cancel out, leaving us with y is equals to mx plus b. So that is the slope-intercept form. So the last form of the line of the equation is the point-slope form. So let's go ahead and talk about that. So the point-slope form to do this one, I'm gonna go ahead and draw a line. So over here we have this. Now I'm gonna go ahead and draw a line right here. And as you can see, this is pretty similar to the line we have over here. Now what we're going to do is we're going to take 2 points, again like we did previously, but instead of taking one on the intercept, we're going to take it simply on the line. So one over here, x, y, and then one over here or here, anywhere you like. And we're going to call it HK. So before we get started, what is the point-slope form? Well, the point-slope form is written as y minus k is equals to m times x minus h. So how does this make any sense? Well, I think you can see how this one works out. So before solving this, you can go ahead and try pausing the video and try proving this by yourself before we discuss it. Okay, so let's go ahead and get started on how this makes sense. Now, this is pretty similar to the previous proofs that we just did. So we can take one point to be 1 and then the other point to be 2. So actually instead I'm going to take it the other way around. So this will be 1. Oops. So this will be 1 and this will be 2. So we're going to go ahead and substitute that in. So we're going to find the slope, which is m. So that is delta y divided by delta x, which is y2 minus y1 divided by x2 minus x1. So let's go ahead and substitute that in. That would give us y minus k divided by x minus h, because x and y are our second point, and then hk is our first point. So that would give us this as the slope. So we have m is equals to y minus k divided by x minus h. Now, it's pretty simple from afterwards. We would simply have m is equals to y minus k divided by x minus h. Oops, actually that's not what I meant to do. Let's go ahead and keep it how it was before. So we'll just multiply both sides by x minus h. So that would give us, well, the x minus h cancel out, leaving us with y minus k is equals to m times x minus h. So those are the three forms for equations of a line. So thanks for watching this video. And if you liked it, be sure to drop a like and subscribe. Thanks for watching.